This video explains how niobium-bearing high-temperature processed steels can deliver technical and economic advantages to major line pipe projects. They allow steelmakers to provide a product that meets demanding strength and toughness requirements, enabling the manufacture of high-strength pipes with larger diameters and increased wall thickness for complex projects in demanding environments. HTP metallurgy brings significant benefits to steelmakers by permitting higher than normal finish rolling temperatures, which not only improves the properties of their product, but reduces loads in the rolling mills, increasing productivity and reducing wear on their equipment. The lower carbon, higher niobium design can be used to produce plate and strip with higher strength and toughness, up to X70 and X80 strength levels and beyond. This superior product enables the supply chain to manufacture larger diameter, thicker walled pipes, improving safety and meeting the needs of the most demanding pipeline projects. The modern HTP concept is built on research which is now some 50 years old, and in its current form was actually validated in production over 40 years ago. This design employs carbon levels of 0.05% or lower, and utilizes niobium levels of up to 0.11% to achieve strength levels up to X70, with combinations of other elements such as chromium, nickel and copper to increase the strength up to X80 level. The first significant commercial application of HTP steels following full-scale validation was during the 1990s, when 65,000 tons were used in the Cantorell X70 sour service offshore pipeline. In the following decade, 38,000 tons were used in the Cheyenne Plains project, the very first significant X80 project in the USA. However, the most significant commercial breakthrough for HTP steels came when the Chinese National Petroleum Company, CNPC, developed a specification based largely on that used for the Cheyenne Plains project for their thick-wall X80 second west-east high-pressure gas pipeline. The project consumed 2.5 million tons of HTP-class low-carbon 0.10% niobium chromium material. More recently, a similar specification, this time without chromium, was used in X70 strength HTP steel for sections of the Trans-Anatolian and Trans-Adriatic pipelines. You can hear more about these projects from the supply chain in an accompanying video. Metallurgically, niobium retards recrystallization and recovery, and in solution lowers the austenite to ferrite transformation start temperature. These effects, combined with the higher finishing temperature, contribute to the development of superior mechanical property combinations in plate or coil being provided to pipe manufacturers. The pipes ultimately produced have an inherently improved resistance to ductile fracture propagation, and the low-carbon, higher niobium design uniquely improves weldability both in the pipe mill and in the field. In every respect, this provides a superior product to end users. It has inevitably taken time for the industry to fully embrace the HTP technology, but encouraged by enlightened end users and entrepreneurial individuals, the world's most influential API and ISO standards are now under revision to fully accept HTP steels in a manner which enables alloy designers to more effectively utilize the benefits of higher levels of niobium. Niobium has played a pivotal role in the successful metallurgical design, manufacture and build of major pipeline projects around the world. The HTP story is compelling, and there is an irresistible wind of change blowing which, if harnessed, would deliver significant technical and economic advantages that the line pipe industry would be ill-advised to ignore.